This is day 6 of coding every day until I hit 1K subs. So I had a bit of a hiccup with the latest Leetcode Daily video. My custom code editor was acting up, and I managed to get it halfway fixed. But with 2 flights today, I just didn't have enough time to completely fix it and re-upload. I decided to leave the video up for now, since it's still somewhat understandable. The good news is, the code editor will be all good to go for tomorrow's video, so hopefully, you'll see a nice jump in quality. Alright, spoiler alert. We're diving into Leetcode problems now. Today's daily challenge was alternating groups too, but I figured I'd warm up with alternating groups first. The first problem gives you an array called colors, representing a circle of tiles. Each number in the array is either a 0 for red or a 1 for blue. You need to find alternating groups, which are 3 consecutive tiles where the middle one has a different color than its neighbors. And, because it's a circle, the first and last tiles are considered neighbors. Here's my solution for alternating groups I, and it worked on the first try. I added the first element to the end, and the second last element to the beginning of the input array, so I could easily check neighbors. Then I looped through checking the if that condition for the current color being an alternating group is true, incrementing the count if it does. This runs in big O of n time, because we're just iterating through the array once. Alternating groups 2 is similar, but instead of groups of 3, you're looking for groups of size k. An alternating group is where every k consecutive tiles in the circle have alternating colors. The first and last tiles are, again, considered neighbors. Here was my first shot at alternating groups 2. I doubled the colors array to handle the circular wraparound. Then, I have a nested loop. The outer loop goes through each starting position, and the inner loop checks the next k tiles. Inside the inner loop, if the current tile is different than what we are expecting, check to see if we are at the kth position. If so, add to the sum. Otherwise, we update temp. If the element is the same as temp, break the loop. This solution worked for the example test cases, but it was too slow. It failed with a time limit exceeded error. My solution was big O of n times k, and with the constraint of 10 to the power of 5, that was just too much. I tried to come up with a one-pass solution, but it took me a while, so I ended up looking at someone else's solution. Here it is. The key is to keep track of the length of the current alternating sequence. We loop through the array, but we extend the loop to length plus k1 to account for the circular nature and the group size k. The index equals I modulo length line gives us the correct index, wrapping around when needed. If the current color is the same as the last color, we reset the alternating count. Otherwise, we increase it. If the count reaches k, we've found a group. This one is big O of n, since even with the extended loop, it's still proportional to the size of the input. That's all for today. Don't forget to like, subscribe, and comment down below with any ideas you have for this series. If you are feeling generous and want to help me continue making these videos, you can donate at buymeaboba.com. Link is in the description.